All right, so with day 2 of section 6, we've got 2 concepts to go through, one of which is very similar to one of the things we did a couple days ago on Wednesday. Do you remember what we did on Wednesday where we multiplied everything back out to see what the equation started with?
Yeah, I remember.
Okay, I'm going to do the same thing for that. The only difference is this time I'm not just going to give you numbers or whole numbers, I'm also going to give you imaginaries to go along with it. So if I give you something like this where I said that you have to multiply it back out to come up with the equation and the zeros are 2 and 3i, I'm going to tell you that one of them is missing. Which one's missing? Nope. Negative 3i. Right. Remember, the I is like a square root, so therefore it should have plus or minus. We just did one a little bit ago that had plus or minus I root 2. So if you have an I, you should also have negative I. All right? You should always have plus or minus because those are actually square roots. So remember what we did a couple days ago? This was on Wednesday where we said x equals 2, x equals 3i, and x equals negative 3i. And then what did we do after that? X minus 2 equals 0. X minus 3i equals 0. X plus 3i equals 0. What that's called is you set them equal to 0 again. Then from here, we started multiplying, right? Which 2 do you want to multiply first? The i's? Okay, me too. So when you multiply those together, x minus 3i times x plus 3i, okay, FOIL it out. What's x times x? What is x times positive 3i? 3ix. Very good. What's negative 3i times x? Negative 3ix. And what is negative 3i times positive 3i? Negative 9i squared. Now this part cancels each other out. Negative 3ix and positive 3ix cancel each other out. But does anybody remember what I squared was equal to? It was negative 1. Right. I squared is equal to negative 1. So what I'm going to do is, anytime I see an I squared, I'm going to replace that with a negative 1, which means on this part, it's negative 9 times negative 1. What's 2 negatives? Yep. So I get x squared plus 9. And then I have to multiply that by x minus 2. What's x squared times x? What's x squared times negative 2? What's 9 times x? And 9 times negative 2? Negative 18. And you did a great job. Would you like me to do another one?
Yes.
Zach said yes.
Yes.
So we'll go with yes. Okay, here's one of the problems that looks like this. There is some missing, I believe. What's missing? 1 minus I is one of the ones that's missing. And 2 plus root 3 is missing. Now, looking at this particular problem, how many solutions did it have? 5. You had the 2, you had plus or minus 1 plus or minus I, and you had 2 plus or minus root 3. So therefore you had 5 things. So what is going to be my highest exponent then?
5.
Right. Okay, that's what's going to happen. Now when we set these equal, again, remember that was x equals 2, which means that's x minus 2 equals 0. That was x equals 1 plus I. So when you move it over, it's x minus 1 minus I. X minus 1 plus I. Notice that the only thing that changes is the i's. What's the square roots going to look like? X plus or minus 2? Minus 2 plus root 3. And x minus 2 minus root 3. Okay, again, if I set each of those equal to x and then moved everything over, that's what I would have. Now, that's a lot of stuff right there. But you can do 2 at a time. So, which 2 do you want to do first? Okay, Edie said the square roots. So we're going to do them first. We're going to do these 2 first, all by themselves. So x minus 2 plus root 3 times x minus 2 minus root 3. And now it's time to put on the FOIL. What's x times x? What's x times negative 2? What's x times negative root 3? Negative root 3x. What's negative 2 times x? Negative 2 times negative 2. Negative 2 times negative root 3. 2 root 3. Root 3 times x. Root 3 times negative 2. And negative root 3 times positive root 3. What's the square root of 9?
Negative 9. No, that's the answer.
No,
I mean, negative 3 is the answer.
negative 3 is the answer. There you go. Okay? That's okay, Chandler. Good job. Nice try. All right, so if I combine like terms there, I got x squared minus 4x. These cancel. Plus 1, and those cancel. So now, what I want you to do is I want you to take that and just put that on the back burner for a second. Let it simmer. What's the next 2 I want you to multiply, probably? The i's have it. You're right. So now I'm going to go x minus 1 minus I times x minus 1 plus I. What's x times x? What's x times negative 1? What's x times I? What's negative 1 times x? What's negative 1 times negative 1? What's negative 1 times I? What's negative I times x? What's negative 1 times negative I? What's negative I times I? Negative I squared. But what was I squared? So 2 negatives make it a positive 1. Good. So when I combine like terms there, I have x squared minus 2x. Ix's cancel. Plus 2. I's cancel. Now what? Okay, so here's what I have. Right now I have the result of the first 2 multiplications and the result of the second 2 multiplications. So now what can I do? Do those 2. Sure. So what's x squared times x squared? X to the 4th. What's x squared times negative 2x? What's x squared times 2? X squared times 2. Negative 4x times x squared.
Negative 4x times what?
Negative 4x to the 3rd. Negative 4x times negative 2x. 8x squared. Negative 4x times 2. Negative 8x. 1 times x squared. 1 times negative 2x. 1 times 2. And when I combine like terms there, I got x to the fourth minus 6x to the third plus 11x squared minus 10x plus 2. Whew! How are we doing so far? Awesome. Guess what? We're still not done yet. Remember, we got one more piece to go. We have x minus 2 to multiply to all that junk. Okay? So that was x to the fourth minus 6x to the third plus 11x squared minus 10x plus 2 times x minus 2. Whew, this is a big one. X to the fourth times 1x. X to the fifth. X to the fourth times negative 2. Negative 6x to the third times x. Negative 6x to the third times negative 2. 11x squared times x. 11x squared times negative 2. Negative 10x times x. Negative 10x times negative 2. 2 times x. 2 times negative 2. Combine like terms. X to the fifth had no friends. Right answer. Minus 2x to the fourth minus 6x to the fourth. 12 plus 11. Negative 22 minus 10. 22 plus 2. No, sorry. 20 plus 2. Minus 4. Woohoo! Okay? You can thank Zach for that one. That one is in your assignment, just so that you know. Okay? He didn't pick it, but I just did it. Okay, now, that's probably the highest you're ever going to see, where you had 5 pieces to do. Okay? Now, realistically, all it was a whole lot of FOIL, right? Not too bad, though? Okay, now, the last thing that we're going to talk about is we're going to talk about the problems that we did yesterday, but we're not going to do them all the way out. I'm going to give you another option as far as helping you get rid of your list. On the thing that we're going to talk about today for this part is called Descartes' rule of signs. Okay? Just so that you guys know who Descartes was. René Descartes was a French mathematician in like the 1600s. And what he did was, he did a lot of things for algebra. One of them is, when we graph, we are graphing on the Cartesian coordinate plane, is what it's called, the XY plane, named after him. That was because of him mapping stars and whatnot. He also gave us this rule of signs. And what the rule of signs does is it allows us to figure out how many of each type of solution we're going to have based on how many sign changes we have. So the second half of your problems are going to say this. It's going to say how many of each type are you going to have or can you expect to have. It does not say find them. It just says how many of each type do you expect to have. Yesterday I gave you problems that said how many are you supposed to get, and you were like, well, 5 because the highest exponent is 5. Awesome. But today what it's going to say is how many of each type can we get. So how many positives are we supposed to have, how many negatives are we supposed to have, and how many imaginaries are we supposed to have. We're going to figure that out all based off of Descartes. Okay? So here's how it's going to work. They're going to give you a problem like this. I'll give you a nice big long one. X to the 6th minus 2x to the 5th plus 3x to the 4th minus 10x to the 3rd minus 6x squared minus 8x minus 8. Okay? Now, as you're writing this down, here's what we're going to do. All we're going to do is count from one term to the next if we made a sign change. Okay, so if we go from positive to negative or negative to positive, that's a sign change. So, from the first one to the second one, did we have a sign change there? Yes. So that's one so far. We went from a positive to a negative. How about from the second to the third? Did we sign change?
No. Yes.
Yeah, so we're up to 2. Did we sign change? Mm-hmm. So that's 3. Did we sign change? No. Sign change? No. Sign change. No. So we had 3 sign changes, right? So that means we could have up to 3 positive solutions. All I did was I counted the number of sign changes in the original problem, and that's going to tell us how many positive answers we're going to get. Okay? So we could have up to, for the positives, 3. Now, if I said 3 of them are going to be positive, that means I got 3 leftovers, right? Okay? So there's a couple of other options that could happen though here. The next part of Descartes' rule of signs is going to be this. In order to figure out the negative number of solutions, you need to replace x with negative x and simplify it. So here's what that means. The official rule, or the official way to do it, is you're putting negative x in and seeing what you get. So negative x to the 6th minus 2 times negative x to the 5th plus 3 times negative x to the 4th minus 10 times negative x to the 3rd minus 6 times negative x squared minus 8 times negative x minus 8. What, Tamara?
Why did you put a negative x on the Because just the same as negative?
This is, all it's telling you is I want you to replace x with negative x. If I took a negative 6 times, is that a positive or a negative answer? Positive. So that is a positive x to the 6th. If I took a negative x 5 times, is that positive or negative? Negative 5 times. Negative times a negative is a positive. Times a negative is a negative. Times a negative is a positive again. Times a negative is a negative. So if you're an odd power of negatives, you should be negative, right? But there is a negative sign in front of the 2. So there's 5 negative signs from this one and 1 from that one, which makes 6. So therefore, is that a positive answer or a negative answer? Positive. Good. So that's a positive 2x to the 5th. On the next one, I have 4 negatives here from the exponent, and I have a positive in the front. So 4 negatives, is that positive or negative? Positive. The next one, I have 3 negatives from the exponent and 1 from the front. So it's a positive 10x to the 3rd. I have 2 negatives from the exponent and 1 from the front, which makes 3. So is that a positive or negative? Negative. Good. I have 1 from here and 1 from there, which makes 2 total, which makes a grand total of? Positive. Good. How many sign changes did it go through?
1, 2, 3, 4.
No. 1, 2, 3. No. 1, 2, 3. That's how many licks it takes to get to the center of the Tootsie Pop, right?
Yeah.
So we got negatives that resulted in 3, which some of you are probably thinking, well, why did we even go through that if we said, well, if positives are 3 and there's supposed to be 6 answers, then I should have 3 negatives right away, right? No. Because there's also imaginary solutions that could happen. Imaginaries always come in pairs. That's why we always write plus or minus, right? Okay, so here's how you actually answer that question. The way I do it is I kind of set it up in a chart type thing. The first thing that we could have is I just put positive, negative, imag. If you have 3 positives, you could have 3 negatives, which would mean that's a total of 6, right? And the highest exponent I gave you was 6. So how many imaginaries would you have if you had that scenario? You'd have 0. Now, what if I had 3 positives then, and I decreased this by 2? Because remember, imaginaries always come in pairs, right? So that would mean I'd have to have 2 imag. Another scenario that could happen is, what if I decrease this one by 2? Could I still have 3 negatives here?
Yeah.
Yep, because remember that was the highest I could get. But then how many imag would I have? 2. What's the other scenario? Oh, hold on, we got 2 more. What if I had 1 positive and 1 negative? That'd be 2 out of the 6, which would make 4 imag. Right? And what's the only other thing that could happen? It could all be imaginary. Okay? But when you have 1 and 1 like that, you're not going to be able to go from 1 down to 0. When you come out with this kind of concept, when you figure out the number of initial sign changes like that, it's always going to decrease by 2. This particular thing was an odd number over here for the positives or negatives. I can't get this down to a 0. If I subtracted for 2 from each time, I can't get that to be a 0. So the one option that you guys told me that we could have all imaginaries would not apply here, because there was an odd number of sign changes to begin with. If there would have been an even number of sign changes, then yes, we could have. Like, let's say there would have been 4 sign changes, then yes, I could have had 4, 2, or 0. But when it's 3 and 1, I can't decrease this by 2 and say that that's negative 1. I can't do that. So the criteria or the possibility of having all 6 be imaginaries is not an option.
So I have to do that for every problem?
This is what you have to do for the second half of your assignment. Is count the sign changes and then try to come up with the different scenarios. All right, I'm going to do one more with you from your assignment too. Okay, so how many sign changes do I have?
0.
1. Thank you, Sarah, for sticking to your guns. X to the 4th with no sign in front of it is a positive, so therefore I went from a positive to a negative. That was 1 sign change. By the way, how many should I have total?
4.
4. Okay, why 4? Right, because the highest exponent's 4. So if I had positive, negative, imaginary, can I abbreviate it like that? Okay. You said I had 1 sign change, yes? That means the option for positives is 1. If I put negative x in there, negative x to the 4th minus negative x to the 2nd minus 6, a negative 4 times is what? A positive, right. And what's negative x to 2 of them? Positive, but then there's a negative in the front of it, which would make it what?
Negative.
Yep. Minus 6. How many sign changes would I have there? 1. So if I had that scenario, and I needed 4, and I had 1 positive and 1 negative, 2 imaginaries. Now here's the catch to this one. Can I subtract it by? Can I subtract the positives by 2? can't have a negative number for number of solutions. Can I subtract the negatives by 2? No. So guess what? This is the only option you have. If that number is 2 or higher, you are going to have more than one option. But if they're both 1s, that's the only option you're going to get. No, you have to write the options. It wants you to tell me, it says determine the possible number of positive reals, negative reals, and imaginary zeros for the function, and all the different possibilities that you can have. So for that particular case, that's the only possible we have. On the previous one, these were the possibilities we could have. So that's how I'm going to write these problems. This is how the answers are. Okay? Try not to make the putting in the negatives so difficult for yourself. Just look at the signs and figure out how many, if it's a odd or even number of them, and if it's an even number, it changes to a positive. If it's an odd number of negatives, it's a negative. Okay? Do you want me to do another one?
No.
No? Okay, because, again, you're not solving anything today. So on page 202 to 203, 21 to 27, and 33 to 39, odds on all of them. Okay?